Hey everybody, this is Mr. Walsh, and I just am making a video to go over the practice problems from the notes. You can also use this video to help go over how to make Lewis structures, because we're going to follow the 5 steps even more so than we would on a homework problem or homework key or a quiz key or something like that. Okay, so let's look at NCl3 here. Okay, first of all, we can probably come up with the name of this. We could call this nitrogen trichloride if we wanted to. Okay, but the purpose of this is to come up with the structures, Lewis dot structures. So step number 1 is to count valence electrons. So we look at the periodic table and we find that nitrogen has 5 valence electrons. And then we look at the periodic table again and we look at chlorine. Chlorine has 7, and there are 3 chlorines. So each of those come here and we get 26 valence electrons. So now that means that we have to put 26 valence electrons around this structure, and we're gonna do that by following these steps here. Okay, so we're going to make a skeleton structure. Okay, in order to make a skeleton structure, we have to decide what the central atom is. The central atom is almost always nitrogen, okay, unless the first element listed is hydrogen. And then hydrogen can never be a central atom, so then it's the next one usually. Okay, and then we're going to connect, I'm talking about hydrogen there. We're going to connect the nitrogen with all these chlorines. Okay, so we have N, these are Cls. Okay, and by doing that, a line represents 2 electrons. So that's 2, 4, 6. So we're going to subtract 6, so we're down to 20 electrons. Okay, we've already put 6 in our structure. Okay, so we connected that, and then it says complete the octets of the exterior atoms. Okay, so we're going to come here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So I've used 18 electrons. I'm down to 2 here. Okay. And so we've completed the octet. So again, a little review. This counts as 2, 4, 6, 8. Okay, this line counts as 2, 4, 6, 8. That's the octet rule. Okay. And then we could do that here. Okay. And then it says if there's extra electrons, they go around the central atom. So extra electrons we're going to put right around here. Okay, and that's another 2, and now we're down to 0 electrons. We've placed all our electrons. So now it says we're going to check octets. That's how we do this. Okay, so we know the exterior atoms already have octets. Okay, but now we check the central atom. So 2, 4, 6, 8. Okay, that checks off. So now we don't need to do number 5. Okay, so now we can do the same thing. We can follow the same steps. See if I can get it in the picture here. Okay, so we're going to follow the same 5 steps using this. And again, we can do this. This is selenium difluoride if we wanted to. Okay, but let's come up with the Lewis structure. Selenium has 6 valence electrons, plus fluorine has 7, and there's 2 of them, so we're going to add 7 twice. So that's going to be 20 electrons that we have to deal with. Okay, so we've counted valence electrons. So now let's make a skeleton structure. Selenium goes in the middle of our structure. That's the central atom. Okay, and now we're going to connect the central atom to the exterior atoms by making bonds. And each line again represents 2, so that's 2, 4, so that's minus 4, so we have 16 valence electrons. left. Okay, so we're going to complete the octet of the of the exterior atoms. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So minus 12 is 4. And then we're going to put the extras around the central atom. 1, 2, 3, 4. So minus 4, that gives us 0 electrons left. 2, 4, 6, 8. Okay. Let's do this now for this compound. Now this has hydrogen in it. Okay, hydrogen can never be a central atom, so that's something that we have to do. But let's count valence electrons. Okay, I won't name this. This has a special name. The special name of this is methane. Okay, but let's see here. CH4. So C is 4 plus hydrogen is 1, and there's 4 hydrogens. Okay. Common mistake, people will say that this has 6 valence electrons. Okay, it's not 6, it's 4. And hydrogen only wants to have 2, but it's starting with 1. So when we do this, we have 8 valence electrons. Okay, so we've counted. We've counted valence electrons. So now let's make a skeleton structure. Okay, the central atom is carbon. And then we're going to bond all of these to hydrogen as we go around here. Okay. Now by doing that, we've done 2, 4, 6, 8. We've used 8, so we're done with electrons. We can't add electrons anymore. One of my standards that I use is I say that if you have too many electrons or not enough electrons, you're going to get the structure wrong. You have to at least have the right number of electrons in your structure. Okay. So now we're going to complete the octets of the exterior atoms. Okay, but we don't have any electrons to do that. But if we look, hydrogen, remember, hydrogen is special. Hydrogen just wants 2 electrons. In order for it to be happy. Okay, so if hydrogen just wants 2, if I look at that guy, that only has 2 valence electrons. It's sharing this. It has its 2. This has 2. This has 2. This has 2. All of those hydrogens are happy. Okay. And then we don't have any extras, so this guy doesn't have, the carbon doesn't need to have any extras. And now we're going to count the number of valence electrons around the central atom. So there's 2, 4, 6, 8. So carbon is also happy. So that structure is good. Okay. Hydrogen is a little bit easier to work with. Okay. So now let's do PBr3. Okay. So this is phosphorus tribromide. Okay. So we're going to count valence electrons. Phosphorus is 5 plus 7 plus 7 plus 7. So this is 26. Okay. So we're going to put phosphorus in the middle. The first one usually goes in the middle, again, unless it's hydrogen. And then we're going to connect it with all the bromines. Okay. Br. Okay. So that has used 6 electrons. So now we're down to 20, right? 2, 4, 6. Lines represent 2 valence electrons. Okay, so now we're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. There's going to be a lot of these exterior atoms that need 6 electrons. Okay, but we did 18, so we have 2 left. That completes the octet of the exterior atoms. We have leftovers, so the leftovers are going to go around the central atom. Now we check the octet of the central. 2, 4, 6, 8. That's happy. Everything is happy. There's the structure of phosphorus tribromide. Okay. So now this is carbon dioxide. Okay. Carbon dioxide, okay, has a Again, if we're going to count valence electrons, carbon dioxide has 4 plus 6 plus 6. So that's 16 valence electrons. Okay. So we're going to put carbon in the middle, oxygen on either side here. Okay. And so by doing that, we've used 4, so now we have 12 valence electrons. Okay. So we're going to complete the octet of the exterior. 2, 4, 6, 2, 4, 6. So we've used 12, and we're down to 0. Okay, there's no extras, so guess what? They don't go around the central atom. So now we're going to check the octets. And this is where everybody gets, I don't want to say lazy, but they just kind of forget that we have to check the octets here. Okay, let's check the octets. Okay, the central atom, we just finished the octets, so those are the exterior atoms, we've just checked the octets, so we don't have to worry about those. But look at the central atom. Look at carbon. It only has 2, 4. So in order to get that, to have the right number of valence electrons, we're going to make multiple bonds. Okay, and so that means we're going to take and we're going to move this, and we're going to take these 2 electrons, and we're going to just kind of move them in. Okay, and now this carbon, which instead of having these having oxygen have these electrons all to themselves, oxygen is sharing with this carbon. And so now carbon has gone from 4 electrons to 2, 4, 6. Okay, and then we do the same thing on the other side. Okay, because we have to get up to 8. So we're going to take these 2, and we're going to move them in and make a multiple bond here. Now, we don't want to show any of this other stuff. So what I'm going to do is I'm going to rewrite this structure here without the drawing here. So this is kind of like the work, and then this is our final structure. Okay, it makes it better if you show that kind of without all the drawings on it. Okay, and then the last one here is O3, and so we learned very briefly that if it's just one element, not multiple elements, doesn't matter how many there are, we're going to call this oxygen. This is a special type of oxygen. This is called ozone. Okay, but it's still oxygen. Okay, now this provides some interesting dilemmas here. There's only one atom. Okay, so when it comes time to drawing our skeleton structure, what are we going to do? Well, let's first count the valence electrons. So we have 3, so it's 6 plus 6 plus 6. So that's going to be 18 valence electrons. So now what do? Well, we only have one choice of a central atom. So we're going to take oxygen and we're going to put it in the middle. And then we're going to connect it to the 2 other oxygens. Okay, so it's going to look similar to what we did here with this carbon dioxide to start with. Okay, so we did that. So now we're down to 14. So are you ready? 2, 4, 6, 2, 4, 6. So that's another 12. So we're down to 2. So now we're going to take the extras, and they go around the central atom. Okay, so that's -2, that's 0. So we've used up all the valence electrons. Now we're going to check the octets. Make sure to check the octets. People forget, they get lazy, and they don't want to check the octets. We know the exterior atoms have 8, but let's check the central atom. 2, 4, 6. Let me make sure you can see that again. 2, the pair, 4, the bond, 6, the other bond. So in order to make this middle oxygen happy, we have to make a multiple bond. Okay, so we're going to do the same thing that we did over here. Okay, we're going to move a pair of electrons, and we're going to kind of move it in here, so these electrons are now shared between the 2 oxygens. Okay, I don't know, that's not a dot. I was pointing, I think, and then, okay, so to make sure that everybody's clear on the structure of this, I'm going to redraw it because I don't want to show the extra stuff. And so I'm going to go O, O, O. I'm going to show the double bond here. I'm going to show the electrons. I'm going to show that electron. I'm going to go 1, 2, 3. Okay? So those are the problems that we did in class. Okay, everybody, have a great day.